Hydrology and water resource engineering. Next topic, rainwater harvesting in urban and rural areas. Rainwater harvesting in rural areas. Process of arresting and storing rainwater for efficient application and conservation. An effective way for utilizing large quantum of water which otherwise go into surface runoff. There will be two components: rainwater collecting for storage, recharging groundwater. Process of enhancing groundwater storage artificial at a rate exceeding natural rate of recharge. Possible by putting up a small structure enabling structure storage and infiltration. What are the advantages of rainwater harvesting and recharge? Are improvement in groundwater table, water availability in wells, tube wells, the quality of groundwater through dilution, living condition in rural areas, saving energy in lifting groundwater. 1 meter rise in level saves 0.40 kilowatt hour. Reduction in soil erosion due to reduced surface water runoff. Prevention of seawater ingress in coastal areas. Next one, contour bunds. These are the types of rainwater construction measures suited for lands with moderate slope without involving terracing. Suited for low rainfall area where runoff can be stored on slope all along contour of equal elevation. Prevent soil erosion, conserve soil moisture. Spacing between two contour bunds depends upon the slope and soil permeability. Aspect to be considered for designing rainwater harvesting systems are hydrogeologicals of area including nature and extent of aquifer, cover, soil cover, topography, depth of water level, groundwater quality, availability of source, that is surplus runoff, hydrometeorological characters, rainfall duration, pattern intensity, area contributing runoff like rooftop area, etc. Next method, recharge shaft, 2 meter diameter or more, ends in permeable strata. If unlined, backfilled with filter medium. If lined, small conductor pipe leads recharge water to useful for village ponds having top impermeable clay filter. Shaft top projects above bed level of ponds and is taken up to half the full water depth. Top 1 and 2 meter done with brick masonry for stability of the shaft. Half of the water collected in pond recharge groundwater, the other half is used for domestic purpose. Next one, dug well. Abundant and existing dug well can be put to use after removing silt. A periodic chlorination required. Recharge water taken through a delivery pipe via silt chamber to well bottom to avoid scoring. Next one, check dam and nulla plugging. Constructed across streams with gentle slope should have sufficient thickness of permeable bed. Water confined within the bank of the streams. Height not to exceed 1.5 to 2 meter in general. Excess water flow above wall may be constructed with masonry concrete. Downstream water cushion chamber required to prevent scoring. Next, underground check dam or subsurface dikes constructed below ground to retard movement of water. Site to have shallow impervious layer with wide valley, narrow outlet. 1 or 2 meter wide trench dug across stream bed with the depth extending to impervious layer. Trench can be filled with clay or concrete wall up to 0.5 meter below groundwater level. Next one, PVC sheet 3000 psi, tearing strength of 400 to 600 gauge. LDPE film 200 gauge can be used along excavated face of the trench. Next one, percolation tank located on highly permeable soil so as to allow water stored above to percolate and effect recharge. Normal storage capacity is about 0.1 to 0.5 million cubic meter. Tanks created by earthen bunds with masonry spillway built along hilly slopes, gully plug across gullies, small streams using locally available stones, clay, etc. Better selection where slope breaks as to have some storage behind. Prevent soil erosion and conserve soil moisture. Next one, rainwater harvesting in urban areas. Again, there are two components as we know: the recharging rainwater harvesting for storage and recharging of groundwater. Process enhancing groundwater storage artificially the rate of existing natural rate of recharge. Partially putting a small check enabling storage and infiltration. These are what advantages: improve groundwater level, enhance water availability, improve the quality of groundwater through dilution, savings of energy, reduction in soil erosion, etc. Suitable for building having roof area of 100 square meter. Constructed for recharging shallow aquifer pit backfilled with borders at bottom 5 to 20 centimeter size, gravel in between 5 to 10 mm size, and coarse sand at top of 1.5 to 2 mm size in graded form. Next one, backfill pits for smaller roof with brickbats, cobbles, mesh to be provided at top of to prevent leaves etc. from falling and choking. Top sand to be cleaned periodically. Bypass arrangement to be provided before collecting chamber to resist first shower abundant tube wells. Can be utilized for recharging, and as shallow aquifer have dried up. Water channelized for recharging after silt removal from the such well. 10 cm diameter PVC pipes connected for roof drains. First rains allows to pass through the bottom of the drain pipe, which is closed thereafter. Next one, recharging tin of buildings up to 200 square meters and more. Permeable study exists half and 1 meter wide, 1 to 1.5 meter depth, 10 to 15 meter trenches. This is what we see like in rainwater harvesting in rural areas. This is also we see in rainwater harvesting in rural areas as recharge shaft. These are all the rainwater harvesting methods used in rural areas and urban areas. Thank you.